All right, here we are looking at chapter 2.4. This is the chain rule. We can find this on page 133. And we're primarily looking at composite functions when we do the chain rule with calculus. So it's just a matter of having two functions. You've got f of x and g of x. And then you have the composite, which would be f of g of x, where g of x is inside f of x. Or we could see it notated as this way, f of g of x. Anyway, the basics of this is you take the derivative of the outside function, multiply that by the derivative of the inside. So if h of x is equal to f of g of x, so we have g of x placed in f of x, then we have h prime of x is equal to the derivative, so f prime of g of x, times the derivative of g of x. All right, well, let's see how that all plays out. So in our first example, we have y is equal to 5 times the quantity 2 minus x cubed to the fourth power. Now what I did was I color-coded these so you could see that in the blue, we noted that before the outside was a blue color, and the green was the inside. So I'm trying to keep that consistent for you so you can understand and see it. So let's see. Once we do the derivative, what we're going to do is we're going to bring our 4 down, and that's 4 times 5, which is 20. Then the power rule says, hey, reduce the power by 1. So 4 minus 1 is 3. All right? Remember, we keep the inside the same. We don't change the inside because we're not taking the derivative of the inside yet. We're just taking the derivative of f prime of g of x. So whatever this surrounding it, the outside of the function, which is the blue. Then what we need to do is multiply that by the inside, the derivative of the inside. Well, if we just look at 2, the derivative of 2 is just 0, minus, and then if we take our 3 down, and then reduce the power, we get negative 3x squared. Now, since this is multiplication, all things being considered, we can multiply 20 by our negative 3x squared, which will give us negative 60x squared times the quantity 2 minus x cubed to the third power. All right, so our next example involves some fractions as exponents. So if we look here, this is f of x is equal to 9x squared plus 2x all to the 2/3 power. All right? So again, same basic rule. We take the derivative of the outside function, and then we take the derivative of the inside function. So if I take this 2/3 and bring it down, I get 2/3. Remember, the inside stays the same, so I'm not changing that. 9x squared plus 2x. Now I have to subtract 1 from 2/3. So if you do that math, 2/3 minus 3/3 would be negative 1/3. So now I have an exponent of negative 1/3, which means we're going to put it in the denominator, but we'll do that in a minute. And then times the derivative of the inside. Bring the 2 down. 2 times 9 is 18. Reduce the power, we get x to the first power. And then the derivative of 2x is just 2. So we're left with 18x plus 2. All right, so now I've got some configuring to do. I need to move this whole piece to the denominator. And then I have, so if I do that, I get f prime of x is equal to 2 times 18x plus 2 in the numerator. And then my 3 was already in the denominator. So what we do is we move that 9x squared plus 2x to the 1/3 power. And if I want to, I can simply rewrite it. I can distribute the 2 in the numerator, and we get 36x plus 4, and then 3. And I can change this 1/3 power to the cube root. So we get the cube root of 9x squared plus 2x. All right, well, hope that's been helpful for you. Thank you very much. Have a great time. We'll see you soon.